Alright, Ricardo, read step number 1 for me about completing the square. So we're going to transform standard form into vertex using completing the square. It's a long problem. I'm going to put a line down my equal sign to show the left and the right side. Ricardo, is my a value equal to 1? Yes, it is. Giselle, read me step number 2. Class, put your left hand on the parts that have X's. Put your right finger on the one that doesn't have X's. So these two are going to stay, and this one has to move over. Class, how do I move that one over? Class, what's left? Remember, this is 0 here. Alex, read the next step. Here's my formula, side problem. B over 2 squared. Class, put your finger on the B value. Show your partner. Give him a head nod. Sophie, what's our B value?
4.
There it is in front of the X. So we're going to have 4 over 2 squared. Class, what's half of 4? And 2 squared is? 4. So to complete the square, we're going to have to add 4. Now pay attention as an example later in class today that this will change. Okay? Right now, if I add 4 to add 4, it's still equal, right? Alright. Ronaldo, go ahead and read the next step. Put your finger where the sides are X's. We just basically need to factor it. Take 20 seconds with your partner. Go ahead and factor that. Tell your partner your answers. Christian, what goes in there? X plus 2, X plus 2. And Christian, negative 3 plus 4. 1. So if you're using the X to factor, it's A times C is 4, B value is 4. They're actually the same two numbers, 2 and 2. You know you're doing this problem correctly for completing the square if these two numbers are the same. The reason why is we need a perfect trinomial squared. So how do I put that back together, class? These are binomials. Binomials has 1, 2 terms, and then it's just squared equals 1. Amy, what do we do next? So we just added b over 2 squared to both sides. Okay, we got that. Let's take the square root of both sides. Go, purple pen, go. Pay attention when you're taking the square root. Over here, the little invisible number is called the index. It is a 2. Essentially what's happening here is the square root and the exponent are canceling. You're left with x plus 2. Now, on this side, you have to put a plus or minus in front of it. In class, what's the square root of 1? Now, if you cannot simplify that number, you just leave it as a radical. Actually, well, I'll show you what happened here. So this is solve for x, and then I'll show you what vertex form is. So if I just subtract 2 here, the negative 2 is going to go to the left of the plus or minus. X equals negative 2 plus or minus 1. There's 2 solutions here. Use your finger up to cover up one of them. Class, what's negative 2 plus 1? In class, negative 2 minus 1. Negative 3. How does this relate to what we did on the previous problem? On the previous problem, we graphed x squared plus 4x plus 3 right here. And that kind of tells us that our graph should have crossed now through these 2 points, negative 1 and negative 3. See that? Okay. Negative 1 and negative 3. You guys graphed it in standard form. Do you guys know what I'm talking about? Okay. Now, completing the square, we actually have vertex form somewhere up here. Put your finger on it. Show your partner. Give him a head nod. Class, vertex form has how many sets of parentheses? You see 1, so it's actually right here. Let's make that super clear. How about pink? This right here is vertex form. Let's rewrite vertex form down here and show you how that's related to the graph. So now I'm going to put my x plus 2 squared. If you subtract the 1 over here, and you put a function in front of it like y, there is your vertex form. Because the form is y equals ax minus h squared plus k. So class, what would your h value be? Negative 2. And your k value would be what? Negative 1. So that order pair, negative 2, negative 1, put it in green, is actually the same graph here. So it's kind of more complicated to go from standard form to vertex form, but I just might ask you to transform it, and then you just have to use this algebraic skill called completing the square. So I wanted to show you guys how those were related.